Types of functions. Okay, we can have a look and see, before that we worked out what a function was. So a function is where each x value can only have one y value. So if you think about it, if I have a graph, if an x value has multiple y values, so there's one and there's one, it's not a function. So it has to be, you can say it could be a one-to-one function or a many-to-one. Many-to-one means many x values can have the same y value. However, one-to-one means one x value gives one y value. Now we're going to look at one-to-one functions. So each x value can only have one y value. If it's a one-to-one function, it'll pass the vertical line test, and it'll also pass the horizontal line test. So here, this is a function because it passes a vertical line test, but it doesn't pass the horizontal line test. So that's a function, and it's one-to-one. This one is a function that's not one-to-one. This one is a function that passes a vertical line test, but it's not one-to-one. So F, yes. One-to-one, no. Here, this is a one-to-one function. It passes both tests. This is a function, but it's not one-to-one because on that particular value, it touches it many times. So function, no, yes. And one-to-one, yes. This one here is a function, one-to-one, no. Okay, which of the following are one-to-one? So x squared is a parabola. Passes a vertical line test, so it's a function. Does it pass the horizontal line test? No. So it's not 1, 2, 1. Okay. 2x plus 1, it goes through the point 1, has a gradient of 2. So as we go across 1, we go up 2. So there's my line. It passes a vertical and horizontal line test. So we say that's a one-to-one function. So for something to be a one-to-one function, it's got to be a function first. Okay, x cubed. Let's have a look. We sketch x cubed. Looks something like that. Passes a vertical line test and the horizontal line test. So it's a one-to-one function. And 1 on x, it's got an asymptote at x equals 0 and at y equals 0. It's a hyperbola, so it's in that quadrant. It's in that quadrant. Passes a vertical line test. Passes a horizontal line test. So it's a one-to-one function. So we can say each x value only has one y value, and each y value only has one x value. Implied domains. Now, I really like implied domains because you have to work out what x values are possible. So if we look at root x, we can't square root negative numbers, however we can square root 0 or anything positive. So the implied domain of this function is x is greater than or equal to 0, because you can't have a negative under the square root. If we look at this function here, it's a hyperbola. We want to work out what x values we can't have. The x values that we can't have is if we make the bottom equal 0, then this function will be undefined. So I'm just going to say 2x minus 3 equals 0, 2x equals 3, x equals 3 on 2. I'm going to say can't equal, can't equal, can't equal. So x can equal any value except for 3 on 2. If I put 3 on 2 into that, I get 2 times 3 on 2, which is 3. 3 minus 3 is 0. If x is 0, we can't divide by 0. So this function is defined for all real numbers with the exception of 3 on 2, because that would make the bottom 0, and we can't divide by 0. With a square root, anything under a square root has to be greater than or equal to 0. In this case, I'm going to bring my 5 to the other side, so I get negative x is greater than or equal to negative 5. And then I've got to divide my negative to the other side. When I divide the negative, the inequality will turn around. So I get x is less than or equal to 5. If you want to test it, all you've got to do is put a value in. So if I put a number less than 5 into this, say 3, 5 minus 3 is a 2, can square root 2. If we put in a value greater than 5, say 6, 5 minus 6 is negative 1. You can't square root negative 1 in the real number plane. Okay, we've got another square root here. This time it's a parabola. So I say 25 minus x squared has to be greater than or equal to 0. However, we know when we've got a parabola, you need to graph it. So 5 plus x, 5 minus x, greater than or equal to 0. If I sketch it, we've got intercepts at negative 5 and 5. This one's a little bit tricky because if you have a look here, I've got negative x squared, so it's going to be upside down. What values is this thing greater than or equal to 0? Well, it's here, and it's equal to 0, so it's from those values, including those values. Okay, so we're going to say from negative 5 is less than or equal to x, which is less than or equal to 5. Remember, you could also say x is an element of negative 5 to 5 with square brackets. Okay, we've got two functions added together. When you have two functions added together, their implied domain is where the domain of each function, where it intersects. So here, x minus 5 has to be greater than or equal to 0. So x has to be greater than or equal to 5. Here, 8 minus x has to be greater than or equal to 0. So minus x has to be greater than or equal to minus 8. When I bring that to the other side, x has to be less than or equal to positive 8. So if we draw a number line, there's 5. Greater than or equal to 5 is there. There's 8. Less than or equal to 5 is there. They intersect from from 5 to 8. So I say x is an element of 5 including and 8 including. So you can put all values in between 5 and 8 into these functions. If we put a value outside of that domain, say if I put 9 into it, 9 minus 5 is fine, but if I put it into here, I get 8 minus 9, which is negative, which we can't do. So we can only use values between 5 and 8. Like with over here, where we had to draw a parabola to see when it's greater than or equal to 0, here I've got an inequality again. X squared minus 7x plus 12 has to be greater than or equal to 0. X minus 4, x minus 3 has to be greater than or equal to 0. Let's do a quick sketch. 3 and 4, and it's a happy face. So when is this thing greater than or equal to 0? When x is less than or equal to 3, or x is greater than or equal to 4. So that's our domain for this function. Now our next function, they're exactly the same. So you think, oh, it might be exactly the same answer because they've got the same function in them. But this one, when it's here, we can square root 0. Even though we can square root 0 here, we can't divide by 0. So we know that x squared minus 7x plus 12 can only be greater than 0. It can't be equal to it. So if you look at this graph, when is it greater than 0? Here, when x is less than 3, or when x is greater than 4. So if it was equal to 3, the bottom would equal 0, we can't do that. And if it was equal to 4, the bottom would equal 0, we can't do that. Anything in between, 3 and 4, we can't do that because we can't square root a negative number. Okay, hybrid functions. So we've got 3 different functions in this case for different parts of the domain. So I've got negative x minus 1 for x is less than 0. So when I sketch this, what I do is I go, okay, when x is 0, if I put it into this, I get negative 1. So I put an open circle at negative 1. And I know it's got a gradient of negative 1, so it's going to go down from left to right. And that function is defined from 0 backwards. The next one, if I put 0 into it, I get 2 times 0 minus 1, which is negative 1. So I now colour this in because it's going to join up. It's got a gradient of 2, and it goes up until 1. So if I put 1 into this function, I get 2 times 1, which is 2, minus 1, which is 1. So I colour that in because I know it's included. It's got an equal sign, and then it's a straight line between those two values. If I put 1 into this, I shouldn't actually have equals in both of them, but if I put 1 into this, I get a half plus a half, which is 1, so it would join up. And then it's got a gradient of a half, so it's going to go up in a flat way. Now you can actually put these into your CAS as well. Oh, sorry, your domain is all x values. So x is an element of R, and your range is y is greater than or equal to negative 1. Now let's have a look at it on a CAS. Okay, I'm going to get rid of what we've already got in here. Edit, clear all. Now to put in we're going to math 3 in this thing here. I want to put in multiple values, so I've got minus x minus 1 when x is less than 0. I've got 2x minus 1 for 0 is less than or equal to x, which is less than or equal to 1. And then here I've got a half x, so click that, 1 on 2 x, oops, that's not what I wanted, x plus 1 divided by 2, and that's for x is greater than, oops, not less than, x is greater than 1. Okay, and then I'm going to define it. So I'm going to grab all of this, interactive, define, I'm going to make it f of what x. It says piecewise in the calculator. Then when I want to sketch it, I just go into graph and table. I'm going to delete whatever's in there. I'm going to just put in here, because I defined it, I can just go f of x, ask it to sketch it for me, and there's my graph. Now, it doesn't look exactly the same. If I zoom, initialize, yeah, that looks pretty similar to that graph. Okay, so once it's defined and we graph it, you can see exactly what it looks like. Okay, odd and even functions. So if you want to work out if a function is odd, when you sub negative x into it, the solution, when you simplify it, it'll come out as being negative f of x. If it's even, if you put negative x into it, it'll come out as being exactly the same function. So let's test. This first one here, if I say f of negative x, I'm going to get negative x all squared plus 7. If we square negative x, negative 1 squared is 1. So I'm going to end up with x squared plus 7. That is exactly the same as that. So here, that is an even function because it equals f of negative x equals f of x. Here, f of negative x is equal to negative 2x negative x. Let's just fix that up. Okay, so I get negative 2 negative x cubed plus 7. Negative x cubed is negative 1. If I times that outside, I get negative 1 times negative 2, which is 2x cubed plus 7. Now that's not exactly the same as f of x, and it's not the negative of f of x either, because the negative of f of x, negative f of x, that would be 2x cubed minus 7, because negative f of x is negative of negative 2x cubed plus 7, and when you expand that out, you just end up with 2x cubed minus 7. So this is neither. This next one here, 1 on x, f of negative x is 1 on negative x, which is negative 1 on x when I take the negative out. which is negative f of x, because it's a negative of the original function. So this function is odd. Last one, f of negative x is negative x to the 5 plus negative x to the 4 minus 3 minus x. When I put something to an odd power, it's still negative, so negative x to the 5. When I put something to an even power, it becomes positive, so x to the 4. And when I multiply them together, I'm going to get plus 3x. So that's not exactly the same as the original function. So we know if it's exactly the same as the original function, it'll be even. Can I take out a negative? If I take out a negative, I'll have x to the 5 minus x to the 4 minus 3x. Is that the negative of the original function? No, it's not. So this one is neither. Now there's a quicker way, I think, to work out whether it's odd or even in this case of these functions. If you have a look here, I've got an even power. That's like having x to the 0, which I guess we can say is even. So that's going to be even. Here I've got an odd power and x to the 0, and it's neither. Here I've got an x to the 1, it's odd. Here I've got an x to the 5, which is an odd number. Then I've got an even number and an odd number, and it's neither. So if you've only got even powers, or no power at all, so it's just a constant, then it could be even. If you've got odd powers, then it can be odd. But if you've got a mixture of the two, then it is neither.